giving you a voice,
making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now.
Welcome to the Spring F4 CADathon broadcast on First Updates Now. From F4, I'm Levi, and I'll be your host tonight. Our producer tonight is the editor-in-chief of Fun, Tyler Olds. With 7 days to create robots in CAD to face the unique game challenge, Barrier Breakers, some submissions will leave you in awe, while others may not shine as bright. What's important here is that all teams are improving their CAD skills to prepare them for the next season of competition. Let's introduce our judges. To start, we have Nick Kramer from FRC 3512 Spartatronics.
Hey, guys.
And then we have Andrew Lawrence from FRC 299 Valkyrie Robotics.
What's up?
Thank you, Nick and Andrew, for taking the time to make this happen.
Yeah, no problem. It was a bit of a grind.
It was great. I loved it.
Yeah.
All right. So we're going to give a breakdown of what CADathon is, and in this year's CADathon, Barrier Breakers, and how the judging process works. To start, the CADathon is open to anyone who wants to hone their CAD skills. In the span of 7 days, teams planned and designed robots to meet the objectives of Barrier Breakers. Tonight's robots were judged based on standardized rubric and manufacturability, detail, strategic design, strategic execution, competitiveness, and wow factor by our two fantastic judges. Tonight, we'll be taking a look at each of the 25 submissions. As for the game itself, Barrier Breakers is a game played on 2 alliances of 3 robots on a 27-foot by 54-foot carpeted field. Robots earn points in Barrier Breakers by climbing the ramp, breaking and assembling barriers, activating the supercharger to score goals, and climbing using the curl-up bar. We have a lot of great robots, but to kick things off, let's start with one of our giveaways. Tyler, tell us what we're giving away.
Yeah, as mentioned, we have quite a few giveaways we're going to be doing. So the first one that we're going to be doing, these are all from West Coast Products, by the way. Big shout out to them for doing that. But we're going to be giving away some of these wheels that are the 5-inch, I don't want to say compliant wheels because it's not what they're called. They're called the 148 Hella Space wheels. So why not, right? So we actually have 2 sets of those we're going to be giving away. If you're interested in winning one of them, don't forget to make sure you're following the channel and type in space in chat. Type in space, and then we're going to draw for that after rank number 16. We'll draw for that. So space, once again, is where you're going to type in, and good luck to all the teams.
All right, and with that started, let's jump right into our judging. We'll be showing all 25 submissions, but be sure to stick around after your team is announced to cheer on your competitors and have a chance at the giveaways. Nick, start us off with Team 709.
Okay, so 709 here, essentially what's going on here is you're going to notice this is a common theme throughout this CADathon. A lot of teams ended up doing Swerve. 709 is no exception. They're rocking those SDS Mark III modules. It was a pretty popular choice because people wanted to be able to traverse the ramp really well. So with specifics here to 709, essentially what happens is they have kind of this top feeding ball scoring mechanism where essentially it feeds from the top, they can't pick up off the ground, and then it goes down into a shooter. And unfortunately what's happening here is in this game you have to shoot the ball when the ball is touching the floor, and what happens on theirs is the ball comes down and then it goes into the shooter and then it shoots it out, but it hasn't touched the ground yet. So it's effectively illegal. And then their other mechanism that they have is a kind of a fold out climber, but the climber just doesn't have any hooks on the end, so it can't really do that either. So, there's definitely some good ideas here. It's just the execution was a little lacking in the end, for me at least.
I think Nick literally just said everything that I could have. Really, I'm just here to make Nick look good. I think just adding on to that, what I really liked about 709's submission was they had a strong idea in their head of how they wanted this robot to look. And when looking at this robot and judging it, I could definitely tell that they had this concept that they said, this is how this is going to work. And if this works the way we think it works, this is going to be a really successful design. And I think they were 100% correct. Where they fell a little bit short was that concept of, if it thinks the way we think it's going to work. And ultimately, it's hard to judge because this is a design competition, so we don't have a real robot in front of us. But I feel like there's a little bit there that I would be hesitant to put a bunch of faith in.
All right. Next, we have Team 705. Nick, want to start us off?
Yeah, sure. Okay, so on 705, they fell victim to what a lot of teams fell victim to this time around, where they need a ball scoring mech that's low to the ground in order to satisfy the shooting requirements. And to do that, they've kind of put a gap in their frame perimeter, but they haven't added an extra cross member. Which means that there's some big structural rigidity problems with the frame, unfortunately. Let me take a look through my other notes here. This is one where it kind of looks like they ran out of time, like they're missing the pneumatics that would actuate their essentially their intake. Let's see. So this one has a really cool kind of their barrier mech essentially has a driven wrist and a driven shoulder joint, which is really cool. But essentially the gearing on it is way too fast. Like they actually geared their wrist up, which you want to gear it down. So their wrist would kind of be way too fast. And it's one of those things where, if you're going to have an independent shoulder joint and you're going to have an independent wrist joint, you really want encoders on there. So that way you can actually have, some amount of control over where it ends up. Otherwise, your driver's just kind of guessing, essentially, which is not ideal.
Yeah. Sorry, go on, Nick.
No, that's all I have. For
yeah, I was going to follow up then with the raw voltage control. I absolutely love having done that before on a robot. I think it's definitely a way for many teams to control certain mechanisms. When you get to that double jointed arm, though, I mean, with the level of precision you'll need in some parts of this game, especially with the strategy they're going for, I think you're going to need an Austin shoe level double jointed arm to control that. And maybe Austin is secretly behind this team, and if he is, I would wonder where the sensors are, but I'm going to assume that the sensorless double-jointed arm is going to be a little hard to control. So it may not be as easy for them to execute.
All right, our next team 549. Nick, start us off.
Okay, so 549 is a robot that I feel like they were really ambitious. They wanted to do everything that this game has to offer, and I totally understand that. But again, there's just some issues here with, not every mechanism isn't necessarily in the full stage of completion, which is unfortunate. The biggest example of this is the barrier mech. I'm not quite sure exactly what they're going for. I think it's supposed to feed from the ground and then feed up and then hand over to the arm, but like there's so much missing there that it's really hard to kind of see what they had fully envisioned for that. And then this is one where, let's see, the climber also has some issues. So this is kind of a popular thing where teams will just have some sort of arm and then they'll have a hook on the end. But, in order to satisfy the climbing requirements for this game, you need to do a curl up. And, just having a hook on the end of an arm isn't really going to satisfy that requirement unless you're really clever about where your pivots are. And you ideally want some sort of like knee to rest on the contact pad right below the climbing bar. So again, it just kind of falls short in those aspects. My favorite mechanism on this one was definitely their ball mech. It's pretty well realized. They have most everything that they need. And this one actually did account for the fact that they need to be able to hold the ball while they spin up their shooter. So that way they can, spin the ball into the shooter and it'll actually be launched. Quite a few teams had problems with that. They did not have a problem with that. But this is another one of those where they're like they're holding the ball which is good, but they're kind of dragging it on the floor, which may be problematic as they're traversing the course. It'd be hard to know without testing, but yeah, it was kind of my feedback on that one.
Nice. Yeah, and I think my biggest takeaway from this robot is I feel that it would be pretty competitive if it executes the way the designers intend. And kind of a blanket statement doesn't always work that way, but I can definitely see this. I can look at this robot and I can see what the designers were thinking, and I can see that if the robot worked in the way that they were hoping, I would guarantee it'd be scoring points. Like you said, there is a little bit of hiccups there. I'm not sure if the curl up will work as intended, but I think it's a solid submission. I think the designer should be proud.
All right, our next team here is Team 668. Andrew, you want to start us off this time?
I would, but I don't have their thing up. So Nick, do you want to start this one?
Oh yeah, no problem. Okay, so so this is another team that they chose not to go with a barrier mech, which a lot of teams ended up not doing that. If you kind of read into the rules, what you find out is that you kind of have to score a lot of barriers in order to get the barrier ranking point, and it's relatively easy for your opponent to have some sort of passive mechanism to like unscore your barriers. So they decided, we're not gonna mess with this barrier business. We're all about the balls and the climb. So now this is a team that did actually choose to kick the ball rather than shoot the ball, which is great. Now the problem here, for me at least, on their kicking mechanism is that it's direct drive off of that Neo. I would really like to see, some sort of reduction there, potentially, drawn back and let the spring do the work, let the motor retract the mechanism, but instead they're just kind of full bore, they're going for it, Leroy Jenkins, if you will. And then they had a tape measure climber, which, tape measured climbers are super cool. And it would work in a game like 2016. But again, you need to do a curl up in this game for your climber to work. So I just can't imagine that a tape measure climber is going to get you what you need to get a legal climb in this game.
Yeah, those same thoughts. One of the more positive things I actually really liked about this robot, and it's something I always look for all the robots. For those who aren't familiar, one of the things that the team submitted was a list of machines and resources they have, in theory, to build this robot. And this robot, if you look at every single part on there, it's very easily manufactured given the resources they gave. And they didn't go off and say, oh, we have a 30-axis CNC. They had very reasonable, accessible tools that they probably have as their own team. And I was really happy to see that I have a high degree of certainty that I think this team could easily build this robot. So that was a fantastic thing to see.
Yeah, I didn't get the sense that they ran out of time on this one. They just need to, think about how things would be mounted and constructed a little bit harder, and maybe come back to the drawing board again. But
definitely a work in progress, and I hope they iterate more on it.
I agree.
All right, our next team here is Team 672. Nick, what do you got?
Okay, let me pull up my notes. Let's see, 672.
Literally just pulling up notes.
Okay. 672 they were really cool. So they had they borrowed the turret mechanism from Code Orange in 2019. They famously had this turreted elevator, and if you look at how they actually accomplished their turret, I can't remember the name for it, but essentially it's not using
the epicycloidal gear.
Yeah, it's like a cycloidal gear with pins, which is really cool. And theirs essentially does kind of like a half moon rotation, which is really cool. And then it essentially shoots with pneumatic cylinders. So what was my feedback on them specifically? Oh yeah, so this is another one where they're essentially just dragging the ball on the ground as they're they don't have some way of intaking it into the robot. They essentially hold it with their intake until they're ready to shoot with their half moon pivoting pneumatic punch. So depending on how the specifics work out, the pneumatics would probably work. They are using 4 of them, which is kind of a lot. You probably want to get that down to maybe 1 or 2 bigger bore cylinders potentially. I'm not sure how well that would work, but and then let's see here. What else did I say? Oh, so and then they had a barrier mech on the other side. Essentially just an arm with a roller claw on the end of it. Let's see. So this is another one where they're intending to climb with it, and they really just need some sort of like knee or elbow joints. That way they can rest on the pad in order for the climb to work. Otherwise, it's going to be contacting a portion of the goal, which would then rule your climb illegal, unfortunately.
Yeah, more or less the same. I absolutely love the turreted design. I think it is so cool. I really wish that End Effector had a little bit more to offer. There's a lot of teams who made this mistake where they said, oh, if I have a lot of air cylinders or big air cylinders, bigger air cylinders, more force, I can use all that force to launch the ball. If you've extended 2 air cylinders of different diameters before, you'll often find that for the same PSI, the bigger diameter one's going to extend slowly. It's going to accelerate much slower. So while the maximum force that it can output is definitely higher, I don't think it'll have that much acceleration to actually impart energy into the ball and move it a reasonable distance. So I'd love to see something that maybe a cam mechanism or something that has stored energy that launches it a little bit further. Other than that, though, I love the turret mechanism, and I really hope this team iterates a little bit further and perfects this design, because it's a really fun one to play around with.
Yeah, I had one other piece of targeted advice on this. Their arm mechanism, they did end up using a shifter on that. It's just the shifter was not implemented correctly. It would actually just shift them into neutral, which is not ideal. So if you're gonna implement a shifter like this, you want to make sure that you get the fundamentals down to make sure that it's actually doing what you want and the force is being transferred the way that you want. I like the idea of the shifter. It's just maybe take a look at some COTS gearboxes, make sure you fully understand how that sort of mechanism is actually going to work.
For sure.
All right, and now we're moving to our top 20 teams here. Team 700, Nick.
Okay, 700. Oh man, I remember 700. Okay, so 700. This robot threw me for a loop when I first opened it. It is very non-standard. They have this crate. You can't really see it from the picture, but it's not like a standard West Coast drive. It's essentially like they have like a huge suspension, like V shapes. That way they have room under their robot for this massive turret, which is really cool. It's just largely unfinished. The turret doesn't have a way to actually rotate, so it's just kind of free floating right now. And then on the bottom of it, they have essentially like a 2014 style like linear punch with a huge spring. That spring is like 2-3 inches in diameter, which is really cool. It's just so essentially they have a winch that draws it back. It's just they really want some guide rails on that spring, otherwise it could jam as it's coiling up. And again, I'd like to see the turret finished here. And then let's see, they also had a climb. Oh, so my other kind of big problem with this robot is, so they've got an intake on one side, they've got the turn on the other, and the intake is gonna get the ball, but then how is the ball handed off to the turret, and then it can rotate around and still control the ball? It's just they really need to think about like what's going to happen with that ball when I intake it. How am I going to get it where I need it? And they're really not doing that. So it's they put all this effort into this beautiful punch, and with the turret and everything. It's just they just can't really control the ball, so it's really not going to do anything, unfortunately.
Yeah, I had the exact same thoughts. I really like the idea behind this robot. When I first saw the turret, I was like, this is really interesting. I think it's definitely falling. It falls into the trap of really cool idea that really doesn't add much to the design if it's not executed perfectly. And that's really hard. I mean, I can't do things perfectly. So I think it's definitely a better choice for a robot like this to have something like a static shooter that's real simple, that they can play off of and iterate on, spend more effort on. Because I feel like that turret took a decent amount of resources, or at least mental effort, to make. And if they could take that mental effort and all that time and put it towards making a little bit stronger of a shooting mechanism, I think that would be a really fun robot to see play.
All right, we're going to move to our number 19 team here, Team 703, the High Fives. Nick, what do you have?
So this robot, from a glance, is really beautiful. They've got some really awesome pocketing. There's a lot going on. It's really densely packed. This robot's interesting in a way where it essentially, instead of like extending an arm out and then lifting up, they are actually doing it 2019 style, where they lift their entire robot up to the bar and then they lift that back up. Now, unfortunately, there's kind of some issues with the way that they've done that. There's some interference issues throughout the robot. Their bumpers are kind of just hanging there. They're not really attached to anything. And then this is another one where they'll have like a complete mechanism, and then it's just placed in the robot, and then it's not really mounted to anything. So it's like, sure, you have this mechanism and it's complete and it would probably work. It's just you haven't mounted it to anything. So it's just kind of floating in space. So I think they just needed a little bit more time on this to, get this polished up. But I mean, the biggest issue that I have with this robot, unfortunately, is how they're handling the balls. They have these huge, they have a double-sided shooter essentially. So they have these shooters that fold out, and then they have this conveyor that can hold the ball on either side. I'm not really sure why they needed to have it have two sides. They could have easily gotten away with one side, but they have these plates are just really, really aggressively pocketed, to the point where there's just almost no material left. And then they put the battery on top of that, and the entire thing is just going to fold over. I don't care if it's 0.25 aluminum. There's just so little material there that the pocketing is detrimental. It's not adding, it's actively subtracting from the design, which is unfortunate because obviously they spent a lot of time on it.
Yeah, I think one of the things that really stood out to me was that they were using those magnetically levitating bumpers. There's really nothing holding them on, which is unfortunate. And I think without the magnetism, that may be deemed illegal. But to move on to something a little bit more fun, I didn't get this on the first time I looked at the CAD model. I had to look into, I had to read all their documentation. Their breaker mechanism is really interesting. It's a suction mechanism, and it's basically like a semicircle that goes over the breakers. You can see, put my hand in the picture. It's like, it's like a semicircle that pops on over it. And if it gets a good suction, I think they had some foam on the inside to ensure good suction there. I think it was really creative. I know there's a lot of suction has been coming out since 2019 has been really popular. 971 had the suction mechanism for the balls and the cargo hatches that year. I think it's really cool. I'm not so certain that it's a clean and effective solution in this game, but I really liked that they thought of that. I thought it was a really creative approach to a potentially complex game mechanism or game piece to play around with.
Yeah, one final note on this team, just relating to that he was just saying, is this is a thing that I see a lot on CADathon teams where they don't really care about the thickness of material. So like the arms that support their mechanism for that are made out of 1/8-inch aluminum with like no standoffs between them. And I'll tell you from experience, that's going to immediately fold over. So you just pay attention to the thicknesses of your material. If it's going outside your robot, 1/8 inch is not really sufficient unless you have a lot of standoffs, which they did not.
Yeah. One of the best things about CADathon here is that these teams who are watching are going to be able to see really good examples of teams who do these things correctly. And we have a lot of really good robots coming up. So I'm excited for that.
They're already getting good, man. And we're still in the bottom half. All right. Our next team here is Team 566 Sigma Motion coming in at number 18. Okay. Nick, what do you got?
Yeah. So this one, I actually really, really like this robot. They're another team where they're really ambitious. They're doing a lot of the things in this game, and if they had an extra day or two, I feel like they could have gotten a lot of the issues that I saw with the robot resolved. So essentially what's happening is a lot of their mechanisms are complete. They're just kind of hanging in the robot. They're not really mounted to anything, which is not ideal. So in particular, this is actually the first robot that I opened for this CADathon that is using like the kicking style of, the actual 2010 style of kicking the balls. Essentially, what they're doing is they have a cam system. So the cam system pulls back their arm, which is engaging a torsion spring. And then once the cam finally goes up, the kicker, hits out and shoots the ball, which is cool. And most of their implementation on that was really solid. Their cam, again, is made out of 1/8" aluminum. I'd really like to see that, at least quarter-inch, if not more than that. Again, like the climber is the climber system itself is really robust. It's just they don't really have a way of actuating it, so it's just kind of hanging in there. And then they've got a tiny little elevator on the back for them to kind of go in and score the barriers. I just don't see how it's going to pick them up and score them. I think this would work really well as a barrier descorer against the other alliance. I just don't see how they're going to control the barrier with any semblance. And then this is a robot that had really good use of COTS parts. They were used really efficiently here. I'm always happy to see a team, that recognizes I don't need to do custom for everything. I can definitely go with COTS where it makes sense. And they use COTS really effectively here. This is actually my judges award team. So congratulations, 566. I really like this robot. Just wish you had a day or two more to kind of really iron out the design here.
Yeah, and with that judges award, this team will be winning a West Coast Products pop socket with some stickers and a bottle opener. So there you go, Team 566. Andrew, I believe, will be giving his out later.
Yeah, I will be. In terms of feedback and thoughts on Some Ocean's robot, I think it's quite literally exactly what Nick said, and I feel bad that I don't have anything else to say. I'm looking at my notes, and he is literally, it's like he's reading from my notes, except he has much more detailed notes than I. Something I want to reiterate on was I really like the COTS part usage. That was really nice and really refreshing. Because I think Nick said this earlier, a lot of teams will say, oh, it's a CADathon. I'm going to go a little bit extra and giving myself some leniency in what I should make and what I shouldn't make. And it's a really good engineering decision to recognize when you making something is not the right call.
Right. All right. Well, we're going to move to our number 17 team here, Team 708, the Falcons.
Do you want to kick this one off, Andrew?
Give me a second to open it. Every time we switch to a new team, I think Nick and I are closing our old notes and opening our new notes. It takes a solid second.
As long as you're not reading my notes.
Oh, boy.
Well, Chad, as we get into that, just a reminder, we will be drawing once again for the Space Wheels, the 5-inch wheels from our friends at West Coast Products after rank 16. So make sure you type in space in chat. That's your opportunity to win. We'll be drawing 2 different ones, and you only get 1 entry. You can type it in as many times as you want. Now, I don't know if you sub, maybe we'll give you a couple more, but we won't tell anybody that. But let's get into rank number 17.
All right, so I have some valuable things to put in, but I don't have nearly as detailed notes about the robot design as Nick, and I have looked over 25 robots, so I'm not going to go over too much in depth of the design itself because I have a terrible memory and I don't want to get something wrong. What I can say about this robot was I really liked, again, they had the thing that I really look for the most is the parts were manufacturable. Given what they said they could do, I can easily see a very reasonable ability for this team to make these parts and put together this robot, which I'm going to keep reiterating because it's very important, and so many teams don't do this, and it bothers me. Looking at just the things that we judge them on, I'm looking at my judging notes. If I'm looking at the amount of detail, I said it was sufficient detail to imply design intent. It's a really important thing for teams on the judging aspect to convey what's not obvious to the judges. When we're opening stuff, we get the CAD model, we get whatever resources are handed to us, and we do try our best. We try our best to understand how a mechanism works and really try and figure out what the intent is, but sometimes it's not given to us. There's a lot of times we're left scratching our heads, like we don't really know what to do with this. And I really enjoy that their design was their design itself communicated its intent very cleanly. And I thought that was really nice. Another thing I like to point out is I think this robot is a great practice for the designers, but I think the scope was a little bit broad. And I think if the designers could pull back a little bit, narrow down and specify that scope of their robot, they'd have a much better submission if they could focus on a few more things instead of trying to fit as much as they have in there.
Okay, so I can jump into some specifics on this one. They're another team that had a kicker arm. This one actually was probably geared correctly. It wasn't direct driven, which you'll love to see. The problem with it, in my instance, is they essentially have these two towers, which are pretty far away, and then they have the kicker arm right in the middle. And you know what's going to happen the first time you fire that? The hex shaft is going to get twisted immediately. You really want to, you know, if you're going to have a kicker arm like that, ideally you're not using 1/2-inch hex. You would ideally use some sort of round, larger diameter tube for something like that. But if you're going to use 1/2 hex, you really want to keep that to just a few inches. You really don't want it cantilevered right in the middle of a long hex shaft. And then for something like this, you're really going to want hard stops, because what happens is if you look at their design, they have their ball intake on where the kicker is, and without a hard stop, that's going to immediately hit the other hex shafts. So now you got two broken hex shafts. That's not ideal. So again, you know, you want to think about, you know, a lot of robotics teams. A lot of FRC kiddos will, you know, I use 1/2-inch hex. I'm going to use it for everything. I need an axle. I need 1/2-inch hex there. No, not always. You really think about what's going to happen there on a long hex shaft like that. You really want to make sure that, you know, you're going to design your pivot in a way that's going to stand up to the rigors of this. Let's see, what else did I have for them, just for some specifics? Now, funny enough, they did use large diameter. You know, they didn't use 1/2-inch hex for the pivot on their barrier mech. So it's like they know that. They just didn't apply that when they were designing their character, which is unfortunate. They did use chain, which is good. I like to see chain on the final reduction of any sort of arm. That's always good to see. This is another one where they kind of just have their climber hanging out. I mean, their barrier mech hanging out, and there's really no structure connecting it to the frame. So, you know, it's not just about getting the mechanism. You need to support the mechanism. You want to make sure that when it's doing its thing, it's not going to get ripped off your robot. So, but again, as Andrew said, you know, there's definitely clear design intent. It's just, this is another one where they probably could have used a day or two so they can iron out the design.
Right. Nick, you're talking about 1/2-inch hex there. I'm just imagining FRC kids getting out into industry and like working at Ford and building cars with 1/2-inch hex on all the tire.
Oh no, that would be a nightmare.
Oh yeah.
On a positive note of that, I think we did see a lot of examples in the teams that we've seen so far and coming up of teams using appropriately sized, larger diameter round tubes for high load situations, especially like their climbers. So it's really interesting to see that design aspect in the meta, and I think we're going to see that in actual FRC robots when we get back to new normal.
That's right. All right, our number 16 team here, Team 429.
Okay,
Nick, you got your notes up?
Here. Yeah, I'm getting there. Okay, so 429, another team. They decided they want to do everything in barrier breakers, and the execution was just, you know, not all of the mechanisms are fully polished or fully thought out. So so they have essentially what looks like a 2018 cube mech to like grab the balls, and what's going to happen here is all of the, like, their three compliant wheels are all connected to each other. So sure, you'll intake it and you're holding it, and now you need to shoot it, but your shooter wheels are attached to your intake wheels. So if you spin one up, the other spins up. So it's going to eject it, but it's not going to eject it with much force at all, which is unfortunate. You really want to make sure that, you know, if you're going to be shooting something, that you're shooting it with a decent amount of RPM, and ideally you don't want to connect, you know, the place where you're holding the ball with where you're shooting the ball, because then you're not gonna transfer, you know, the momentum into the ball efficiently, which is unfortunate. Yeah, that was my biggest takeaway on this one.
For me, it definitely seemed like a situation where the scope of the robot was just a little too aggressive given what the designers were capable of. which not to say anything bad about the designers, is everyone has their place and where they're at. But it definitely seemed like hey, we're going to do as much of this game as possible, when really they would have benefited from sitting down and spending a little bit more time on strategic analysis, figuring out what was the best approach for them. Aside from that, though, I think they had a really good idea coming into it. And if they brushed up a little bit more and practiced more with robot design, I'm trying to think of the right words to say. I remember when I was trying to evaluate this robot, I ran into a good number of situations where I thought, fundamentally, this won't work the way they think it will. And that just comes with practice. I can't blame them for it. It's not a bad decision. I don't think they knew. One of the things I want to personally tell the designers is your drivetrain is going to fall apart because of how little support there is between the two sides. It's going to bow out like this. And I would hate to see that happen on a real robot. So I'm hoping you're listening. When you have a giant cutout through your robot like that, if it's not really well and structurally supported, it's going to bow out, it's going to crack. And there's a lot of robots who had a similar thing this year during this CADathon. So it's a very important thing I wanted to make sure we stress.
Yeah, I had one final note on this one. I did like that they included a ratchet on their climber. It's just, if you're going to do that, ratchets have a way that they work and a way that they don't work. You have to pay attention to the orientation. Actually, like, literally, I'll pick things up and I'll spin it and I'll think about it in my mind. Okay, so when that goes that way, this is going to go that way. The ratchet is facing the wrong direction. So, good effort, including the ratchet. I like that you're thinking that way. It's just, you got to go to the final step and think, well, how would this actually work in real life? Because you want to make sure that your ratchet's actually going to, do the thing that you want it to do.
They'd figure that out the first time.
Oh yeah.
They'll put it together and be like, I don't understand. Why isn't it? It's a really fun noisemaker.
That was Team 16. So we have a giveaway here. Tyler, what do we got?
Yeah, once again, giving away these awesome wheels from our friends at West Coast Products. If you typed in space, that was your opportunity to go in. Once again, those are the 148 Hella Space wheels. 5-inch compliant wheels. We're going to draw for 2 winners in that. And don't forget, in the F4 Discord, there are also additional giveaways too. So make sure you check it out on there if you're interested in the F4 Discord. So our first winner of that is going to be, there we go, Jetum. Congratulations, Jettum. If you don't mind, please make sure you send either Rohit or myself a message. I'm actually going to say send Rohit a message with your shipping information so West Coast Products can get all that. So once again, first name, last name, mailing address, all that stuff. Sometimes email helps too for tracking. Make sure you send that over so West Coast Products can send that out to you. So that's our first winner is Jetum. And our second winner is going to be RJ919. RJ919. Congratulations for winning that. I just need to make sure I get these down in here so we don't forget who won those. And then we're going to start another giveaway right away. Why not? Right, guys? So our next giveaway. Yeah. Our next giveaway is going to be for these 6-stack pulleys. So it's actually going to be 6 of these that will kind of look, this is kind of how you can make it look. I mean, I think there's more than 6 in here, but that's what it's going to be. So 6-stack pulley is going to be that. We have one of these to give away. We'll draw after rank number 6. And then we have another giveaway after this well too. And the keyword for that is going to be Versa, VERSA. Versa is your keyword to type in. Once again, you do need to be following the channel. I would love to have you do that and stay up to date on all the shows we have coming out. A little bit drier with the first season the way it is, but we're starting to pick back up with live events and all our stuff coming out too. So love to have you join us here in First Updates Now. But Versa, we're going to get into rank number 15.
And they really went all out on that, giving us 6, not just 5 or anything. Wow.
Oh,
it is one more than 5.
That's right.
No, the stackable pulleys are super cool.
All right. Yeah.
Heck yeah.
Our rank 15 team here is going to be team 215, Delta Dynamics. Nick, you have plenty of time to get your notes up.
Yeah. Okay. Thanks for calling me out. I do have them up. Okay. I remember this robot. Because it's ambitious. It's trying to do some really cool things. And again, the execution is a little bit lacking. So like a perfect example of that on this robot is their barrier mech. So their barrier mech is essentially, it's a virtual 4-bar. which is great. Virtual 4-bars are really cool. They give you some really cool range of motion. They essentially have these spools that like fit into the end of the barrier, and then they have a wheel on top that's going to go and spin that, so that way they can articulate the barrier how they need it. So all that's cool. And then the last thing actually is that they actually have a linear slide on their barrier mech, so it'll actually move side to side. Now, I said all those things are really cool. The execution is where things kind of fall apart a little bit. So on their linear slide, they've got this really complicated and heavy bearing setup. And if you actually look at what this thing could actually travel in real life, you can get an inch one way and half an inch the other way. So it's like, there's a lot of complexity there for comparatively very little travel that you're getting. I think that's a mechanism that either shouldn't have been included or should have had some more thought, potentially, go with some linear bearings that, like West Coast Products sells. That would have maybe been a cleaner way to package that. And then the other thing is their virtual 4-bar just would not work. So on a virtual 4-bar, you have to pay attention to, like, you have your base sprocket, and then you have your wrist sprocket, and your base sprocket needs to be locked to the frame, and your wrist sprocket needs to be locked to the intake. Well, these are just kind of free floating. They're not locked. So what's going to happen with this is it's immediately going to fall down, and it's going to sit there, and you're going to power it, and it's not going to actually lift up, which is not ideal. So it's another one of those where, you're trying to style, you're trying to do some cool things, but fundamentally you need to understand how these mechanisms are supposed to work first. Then you can, go crazy and do some really cool designs. So, I really appreciate the ambition in this robot, but it's just lacking when it comes to, robust engineering analysis, essentially.
Yeah, I think you're 100% correct that it is a very ambitious robot in both a good and sometimes hurtful way. One thing I want to point out about the submission is this is a design competition, but there's a lot more than just creating a robot in CAD that goes into this. One of the things with this submission that made it harder to judge was when I opened the CAD model, there were parts missing, and I either didn't load, and I did try a bunch of stuff. So teams are judging a variety of criteria, and one of them indirectly is how well the judges can infer how the robot's supposed to work and judge the robot based off of that. And it's a good idea for teams to open up every CAD model they're submitting and just make sure it works. Even better if you can check multiple CAD systems. There was a point where I opened this robot and most of their barrier mechanism was floating in the air. And I had no idea how it worked until Nick came in and was telling me. He goes, "Oh, this is what it's doing, and it's a 4-bar." I said, "Oh, cool. I didn't know. I can't see it." So knowing that's how it works, I think, again, I'm just going to really turn back to that. Go back to that word. It's really aggressive with what it's trying to do, and it's a really big reach. And I think the designers had a great idea, and that they should definitely try and refine it. But when you have a week for a CAD competition, you probably want to go with something you're more guaranteed you can do well. So same thing with regular season, right? You want to try new things in the off season. When it's January comes, it's not the time to try making soccer ball swerve.
Yeah, like if you look at the rules manual, I don't think the teams at this point know exactly how the scoring rubric works out, but like there's one section for competitiveness here.
Yeah.
So if you build a simple robot that does everything really, really well, that does like one thing really well, then you're going to be scoring a lot of points in a lot of categories, and maybe you're not going to do so hot in the competitives category, but that's one category out of 6.
Oh yeah, there's been a lot of robots that.
Okay, I got to let my dog out. I'll be right back.
There's a lot of robots that scored really well because they fit all the criteria. And I believe the rubric was public. Someone correct me if I'm wrong. I am not knowledgeable about anything. But if you can hit those points of manufacturability, detail, strategic design, I mean, there's 22 40% of your score is based on your strategy. And how well you're able to execute that strategy. So 40% is nothing to scoff at. There's a lot of teams who did those parts really well, and we're going to see them in the next couple numbers because they knew what to do right.
Yeah, and our next team here, rank 14, is going to be Team 713 Safety Tips.
Do you want to tackle this one first? Me and Andrew talked about this one a lot, actually. This is an interesting robot for sure.
Yeah, give me a minute to pull up my notes because mine are not in number order for some reason. They are in random order, and
that's fun.
Oh, it's very fun.
Sounds like something Rohit would do to me.
Oh yeah! Wow, we're editing the slides too.
Right.
Where is it? How about you start off with something because
sure.
I am blind and can't see.
So initially when I opened this CAD model, I was really impressed. There's a lot going on here. They have a super impressive amount of detail. They're really good with their textures and their colors. So obviously these guys have been around the block. They know what it makes to, they know what it takes to make like a really good looking robot. Now, when you start digging in, there's some things that they're not great. So let me kind of tell you what their overall match strategy is. This robot has two shooters, and they're kind of like at a 90-degree angle. And essentially what's happening here is their entire strategy is I'm going to pick up a ball and then I can shoot it out of the left to the right. So if I'm a goalie and I'm trying to cover one of the three goals, then if I go left, then this robot shoots right, which is great. So essentially their entire strategy is I'm going to completely invalidate the goalie because they're never going to know which way I'm shooting, which is really cool. I love that strategy. It's one of the favorite strategies that I've seen out of all the robots. Now, their specific implementation is the part that I take issue with, because essentially what happens is if you look at this robot, they have a bunch of stuff going on, like to internally route their balls to the left side or the right side, but it's mounted on the top with a massive piece of 1/8-inch aluminum, and it's mounted on the bottom with a massive piece of a 1/4-inch plywood. So you have all of these pieces that are mounted between those two things, and it's just like that would be such a pain to assemble. And I'm not sure if I'm going to trust a shooter shaft that has a bearing and plywood to hold up over a season. And then again, this is another robot where, because they have such a huge swath of the robot carved out to handle the balls, there's not a lot of structural rigidity keeping the entire frame together. Okay, no problem.
So on that note, sorry, I got my notes pulled up. I was looking for 714 for some reason, the number 713. That's why I'm dumb. But really, just to wrap up my thoughts on this, because I know we have a lot going on. Like Nick said, the plywood was something of contention for me. He and I had a conversation like, is that plywood? We couldn't tell. I thought it was. He thought it was a 1/4-inch piece of aluminum, which honestly would have probably been a better shot. It would have been super heavy, but that plywood really killed the viability of a lot of the mechanisms. And if you look at how that 45-degree angle or 245-degree angle shooters works, you basically cut off the entire front half of the chassis. So, and you can see it in the picture, the front swerve module and the front right and the front left swerve modules are pretty detached from most of the frame. And I'd definitely be worried about those bending out and bowing. So yeah, I think it was a really good concept that just needs a little bit better execution.
All right, we're going to move into rank 13 here. Team 420, the Bordy Alliance.
Okay. So Andrew, do you want to start on this one?
Yeah, actually, and I should be able to. Here's my notes. Cool.
Hey.
So I really liked this team. And if you look at it, it is a dead simple robot. It climbs, it plays defense, and it doesn't get in the way because they know that that's a problem. The reason I love this robot is, from a CAD perspective, it's not the best model. There's a lot of stuff missing. There's some tubing sizes that don't exist, but I'm pretty sure that's because it was a modeling error, not an intentional choice. There's a decent amount of details missing, so I can't give them points for that. But what I can give them points for was I absolutely love the self-awareness they have with their own limitations. If you look at their documentation and their strategy, I thought was top-notch. I give them an 8 out of 10 in strategic design. because they fully recognized what their limits are and what their capabilities were, and they built a strategy around what they considered to be a reasonable challenge for them in a way that would still add value to their alliance. So they said, okay, we're not going to be designing a really great robot. We're going to try our best to contribute to the alliance the best way we can. So what's important? Climbing super important. Is that we're gonna design a climbing mechanism, and for us, for our resources, for our experience, that is a reach, that is a challenge, but we recognize that. And by recognizing that, they were able to design a robot that I think will do the one thing really well and really reliably. Like, I would love to have this robot on an alliance, because I'd say, hey, here's the deal. I want you to play a little bit of defense and then climb. And if you climb every match, you're getting that RP, you're contributing a decent amount of points to your alliance. And I'm sure they'll have practiced that climb and so much more than any other robot at that competition. And because they're so aware and so honest and realistic with what their capabilities are, I am giving them my Judges Award.
All right, and there it is, our second Judges Award. So they'll be winning the West Coast Products Pop Socket, the stickers, and the bottle opener. Nick, anything to add?
Yeah, I just, again, I totally agree. I appreciate teams that can, that don't overreach, that think about what they can realistically achieve. Yeah, sure, their climbers floating, but overall it's made relatively well. I have some specific feedback that they'll get as far as like specifics. I also think their drive base is a little bit narrow. It may be a little bit prone to tipping, but Andrew really kind of nailed it on the head there. I really like the thought that this team put in as far as their own limitations.
All right, well then we will move to rank number 12 here. It's gonna be Team 649 SRS Tech.
Okay.
Who wants to start us off?
Let me get my notes up.
There's actually a lot of cool stuff about this robot. Not perfect, but I'll start off with certain things that I distinctly remember. This is one of the ones I do remember. Not in any particular order. I really liked that their intake had a barrier descorer on it. So if you look at that ball intake in the front, it has little bars that come down to descore barriers. I thought that was a really creative, passive way of combining mechanisms and adding on functionality without adding too much complexity to the robot. That was really clean. I appreciated it. From there, it does get a little bit more sketch. Their intake and their conveyor system in their robot have more than a ball's diameter's distance between them. So there's really no clean direct handoff from ball intake to conveyor. It's, suck in the ball and hope that you're moving in the right direction or that it centers itself. And that could work in certain circumstantial situations, but I wouldn't be super reliant on it. And I feel like moving those a little closer together and giving yourself more control, more active control over that ball throughout its progression into your robot would be a much stronger design decision. Nick, do you have anything else? I have other stuff I want to give you a chance.
No worries. So yeah, I'll just go ahead and talk about their climber quickly then.
Yes, the climber.
So they are using. So I tried to be generous with them. They have a single stage VP. I'm not sure what size it is. Even using a 10, which is the weakest one, they would not have enough headroom on their climber over their overall ratio for this to climb, which is unfortunate. I would definitely suggest a higher ratio there, and also if you can, try and do something like chain on the last one so that'll handle backlash a little bit better. A versaplanetary is not an ideal gearbox for like a curl up kind of arm style climb. It's just rough out there. You really want to use maybe a sport if you're going to use a VP, maybe some other solution. Maybe a winch type thing would be a little bit better. Maybe pneumatics. A VP is just not really going to stand up to the rigors of trying to climb with an arm style climber. Let's see. Yeah, those really kind of my big feedback on that one was the climber.
Yeah, completely agree. I think the climber had a lot we wish we could have seen, and I was a little questionable about the viability of that sheet metal part they had in there. I was terrified it would bend if there was any side loading from a lifted robot. I feel like this robot would have been a lot stronger if it didn't have a pass-through conveyor for the ball mechanism. It's a simple thing up front. They could focus them a little bit more on that, and that would have been a much stronger choice for this team.
All right, then rank number 11 up next. It's going to be Team 538, Warped Paradox.
So speaking of a team that has kind of a simple thing up front, this is a team that has that. They have 2 rollers on front. They capture the ball. They've got like a pneumatic press plate to kind of launch the balls. Again, I'm not really sure. They've got these tiny little pancake cylinders. I'm not really sure how much force they're going to be able to impart the balls. But I mean, overall, you know, they have this robot is for the most part finished. They've got a lot of detail. And then let's see. Let's give me a sec.
While you're looking for that, I really thought this was a robot that was really attainable by most teams. I think the design is really smart, and it doesn't take a lot of resources to make, and that's a good thing. It's a very good thing that you have a reasonable and attainable design. Alongside that, I put that it is, I think it honestly really could be a competitive choice, that this robot has a very realistic chance of scoring well and playing the game. The ball mechanism is a little questionable. Like Nick said, the air cylinders, I don't think you're going to apply enough force to actually launch it. Aside from that, I think it's a solid submission. I think the designer should be proud of it.
Yeah, the climber was actually really good on this one.
Yeah.
The only thing that I would say is they've essentially got one motor to like flop the climber out, and then they've got a winch on another motor. Try and eliminate that first motor to flop the arm out. Just use a spring or something, right? If you let off your winch, and this is spring loaded, then it's naturally going to flop out for you, and you're saving your drivers having to contend with 2 motors. We did that in 2016. It was not ideal. We took forever to climb. See about eliminating that motor that drives the arm, and just rely on spring power and a winch, and it would be a lot faster and easier for your drivers.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.